sometimes like compromise on rules and regulations.
Rules and regulations. Transportation infrastructure is the level or the structure is amount of structure or the level of it is very different from the, for example, the developed country and the developing country, of course. The developed country and the developing country is different conditions, of course. And also the urban city and rural village is different conditions, of course. Yes, the developed country or the urban city have the many people is gathering, and also so therefore the city government can get many taxes, money. So therefore they can spend much money to the infrastructure development. So therefore this kind of city or this kind of countries can develop more and more. But to the rural village has not so much the income is there, so therefore the people cannot spend money to make the infrastructures development. So that is the same as last week's subject, the not unequal society, sometimes the unequal society. So the developed country people can enjoy much infrastructure and the organized infrastructure, but to the rural village is only the similar to the natural conditions. But of course, for example, the infrastructure, for example, some bridges or for example, railroad or the underground metro, it also has some many product has its lifetime toいうか, the period it can be used. So become the bridge is if you construct some bridge, it is not it cannot hard enough for long time. Sometimes it has been broken. So presently the developed country has to maintain this kind of infrastructures. So it also makes some. It also takes some cost. The much cost has been given has also given to the maintenance cost. Maintenance cost is very, very expensive presently. Sometimes if it's refabricate the bridge, of course, but they want to maintain and keep using so as long as possible, of course. Unequal society. So therefore, this kind of this is also some technology development. Technology can use technology can be used in developed country and also the urban cities. Of course, rich people. It means rich people can use it, but the poor cannot use it. The engineering or technology is the fair, fundamental, but any time the cost problem is there, how much cost it takes. Of course, for example, last week we discussed about welfare technology, but the welfare technology also takes some cost. So therefore, the rich people can enjoy can use this kind of technology so much, but the poor people cannot use it. So therefore, in any case, also in the technology, we should think, of course, cost-benefit ratio, benefit-cost ratio, and if the cost is expensive, the benefit should be lower. The little benefit, but the little cost is appropriate for the many people in some case. The very high benefit, large benefit, but it takes high cost is only for the developed country, only for the urban city citizens. It also says unequal, but some students saying, of course, the education is very important to think, to become, to make the society better, of course. This exercise and the reading your answer to the subject, I'm thinking about this kind of thinking. Okay. はい、じゃあ let's go back to the today's topic, the recent robots and mobility, especially about the mobility. It also has many topics. So therefore, we should look at the glance of all of the topics. ちょっとこのfirst part is about the personal mobility part ね。Personal mobility part is there. この辺ね。それから from this part is a self-driving car. Self-driving car 部分ね。Self-driving car のデフィニッションとかあって、セルフドライブデフィニッションとかあって、でこの辺はそのエシカルトピック。ディレンマの話ね。でそれからスペシャルメカニズム for the パーソナルモビリティというかスペシャルメカニズムです。レクトモビリティ。それからアプリケーションパート。from here is application パートでガードロボットとか、これはガードロボットみたいなやつでサーベイランスロボットとか、それからクリーニングロボットとデリバリーロボットとかね、アプリケーションパート。はい。で、which part you are interested in? どこから始めますか ?From which part we should start? セルフドライビングカーが好きですか ?You like self-driving car? Yes. So, じゃあ、let's start from here. はいはい。セルフドライビングカーですね。セルフドライビングカー。まずはオートモビルセーフティ for automobiles。これアクティブセーフティっていうのとパッシブセーフティがありますね。アクティブはactively to improve the safety, some actions will be there。パッシブセーフティはnot active but to the thing to prevent the crashes。to prevent accident というやつですね。それからペデストリアンセーフティ。だからここにはクラッシュアボイダンス、ドライバーアシスタンス、ペデストリアンセーフティっていう3 categorized into three categories to avoid the crashes. Vehicles headlamp, reflectors, other light and signals, vehicles mirror, vehicles brake, steering and suspensions. And also the many control system is applied to the driver's assistance, such as DA, DS というのは Driver Alternate Detection System とか Automatic Braking とか Infrared Night Vision とかpresently Anti-Lock Brake System とか many functions is presently applied to the present vehicles, present automobiles. This is one category, one way to categorize these technologies for safeties. And the other one is the safety technology is divided into these parts. The one is the ideal driving environment providing, and active safety technology helping prevent accident, and the pre-crash safety technology when some accident happens to reduce the amount of accident as much as possible. というのと、passive safety technology は reducing damage in even the accident. When the accident happens, to reduce the risk of the damage, reducing the damage as much as possible. という this categorization ね。で、ideal driving environment の providing っていうのは zero order safety って言われていて、it is called zero order safety driving position and pedal layout。まあこのコックピットのレイアウトとかデザイン is one thing for the safety. Improved visibility. So the front glass part and this fork っていうか this part, the front and side, this part, these poles, the size and the position is designed to give good visibility. For example, this kind of corners. それからオルガンタイプアクセラレーターペダル、how to make the pedal feel the accelerator or brake pedals, the design, how to このoperation and the input commands relationship とかね。This action and operations relationship we have to think. And the second category is active safety technology, helping prevention accident to prevent as much as possible. So therefore, the safety and comfort together, both safety and comfort should be maintained. And hazards perception, the hazards seed of hazard should be detected, and some hazard should be avoided. So therefore, the many functions, AFS adaptive front light system とか、the HBC high beam control system とか、the ALH とか adaptive LED headlight とか、many kind of the functions for the safety and comfort. And to detect the hazard conditions, rear vehicle monitoring camera とか、lane departure warning system とか、lane keeping とか、ESS emergency signal system とか、forward obstruction warning とか、so this is the measuring the distance to the forwarding vehicles とか、some obstacles. Hazard avoidance brake assist and EBD は electric brake force distribution とか、OWADC、ABS は anti-lock braking system とか、DSC dynamic stability control system、TCS traction control system とかね。many で、これはモビリティについて。それからプリクラッシュセーフティは when it happens some accident to closing to the accident conditions, reducing the severity of damage in the event of collision ということで、スマートシティブレークサポートとかスマートブレークサポート、the acceleration control for automatic transmission。それからパッシブセーフティは reducing the damage in the event of accident で、このフレームワークのシミュレーション、ボディフレームデザインとか SBS エアバッグシステムのwhere it should be put on him. Not only the drivers, but also the back seat passengers also should be maintained by the airbag systems. From the side airbag is there. Seat belt with pretension and the limiter とか言って、この design of the seat belt is also important. And also the injury reduction for the pedestrians. This kind of design for when the pedestrian accident happens, the impact absorption bonnet and bumper system should be designed. This kind of system is equipped in the vehicles presently. And次は self-driving cars, automated driving system, autonomous vehicles, autonomous car. What it is? Having power of self-governance, sensing its environment and navigate without human input. ということで、だから sensing, firstly the environment and the condition, the situation, surrounding conditions is detected and the think by itself, and then the control under the self-governance ですね。A complex combination of various components that can be defined as a system where perception, decision-making, operation of the automobile are performed by electrics and machinery instead of the human driver, and as introduction of the automation into the road traffic. ということで、of course, アンマンビームですね。Classification. The level is decided 5 levels. Level 1は normal, usual, human driver's car. Level 1は individual vehicle control are automated such as electric boost, stability control or automatic braking. Level 2が at last 2 controls can be automated in unizone such as adaptive cruising control in combination with lane keeping such as Tesla Model S. Level 3は driver can fully seize control of all safety critical functions in certain conditions. だから、driver cannot operate in certain conditions. The car senses with when conditions require the driver to retake control and provide the sufficient comfortable transition time for the driver to do so 書いてあるので、when some accident happens, the driver has to take the operation in place of the automations, autonomous control. The level 4 vehicle perform all the safety critical functions, so therefore the completely automated. これは古いレベルで、presently the 2016 level 0は no automation, level 1は driver assistance. Only the driver is main, but the vehicle machine control is assisting the drivers. Level 2は partial automation. Level 3は conditional automation. It means it looks like the fully automated, but the driver should be there and only some conditions, under some conditions. Level 4は high automation で、Level 5は full automation ということで、looks like this. The narrative definition とか execution, steering and acceleration distillation は which human driver か system か、それからモニタリングオブドライビングエンバイラメントが human か system か、それからフォールバックパフォーマンスオブダイナミックドライビングタスクが human か system か、で system capability ドライビングモードは all of the driving mode is in full automation part. How many driving mode is automated is shown here. This is a table developed defined in 2014 by SAE, Society of Automobile Engineers. It also is similar. The level of driving automation looks like this. Level 0, from level 0 to the level 1, level 2, 3, 4, 5. This. You can find many descriptions about that level 0 to level 5, like this. And maybe this is まあこれもシミだ。これか。SA オートメーションレベル。これとか it's easy to understand ね。これとかあるいはこれですね。Advanced Driver Assisting System でレベル1、レベル2、レベル3、レベル4、レベル5で、ドライバーオンリーとかドライバーとオートメーションのパートでドライバーオンリー、アシスティングドライビングでパーシャルオートメーション。それからこれがライダーっていうのは、detecting the laser sensor or to detect the obstacle is essential part of the ADAS. So therefore, the environment recognition is very important. It shows highly automated, fully automated driver です。なんか見ればいいんだよね。はい。ライダーはライトディテクション&レンジング、レーザーイメージングディテクション&レンジングと言われてるやつです。で、こういうやつですね。はい。まあ、レーザーセンサーなんで、the environment is detected by the laser scanning is there, so the surrounding obstacle can detect.なんかセルフドライビングカーありますか？とか一番短そうなやつか。テッドトークの You can find ちょっとこれ How do self driving cars see?
It's late, pitch dark, and a self-driving car winds down a narrow country road. Suddenly, 3 hazards appear at the same time. What happens next? Before it can navigate this onslaught of obstacles, the car has to detect them, gleaning enough information about their size, shape, and position so that its control algorithms can plot the safest course. With no human at the wheel, the car needs smart eyes, sensors that'll resolve these details, no matter the environment, weather, or how dark it is, all in a split second. That's a tall order, but there's a solution that partners 2 things: a special kind of laser-based probe called LiDAR, and a miniature version of the communications technology that keeps the internet humming, called integrated photonics. To understand LiDAR, it helps to start with a related technology, radar. In aviation, radar antennas launch pulses of radio or microwaves at planes to learn their locations by timing how long the beams take to bounce back. That's a limited way of seeing, though, because the large beam size can't visualize fine details. In contrast, a self-driving car's LiDAR system, which stands for light detection and ranging, uses a narrow, invisible infrared laser. It can image features as small as the button on a pedestrian's shirt across the street. But how do we determine the shape or depth of these features? LiDAR fires a train of super short laser pulses to give depth resolution. Take the moose on the country road. As the car drives by, one LiDAR pulse scatters off the base of its antlers, while the next may travel to the tip of one antler before bouncing back. Measuring how much longer the second pulse takes to return provides data about the antler's shape. With a lot of short pulses, a LiDAR system quickly renders a detailed profile. The most obvious way to create a pulse of light is to switch a laser on and off, but this makes a laser unstable and affects the precise timing of its pulses, which limits depth resolution. Better to leave it on and use something else to periodically block the light reliably and rapidly. That's where integrated photonics come in. The digital data of the internet is carried by precision-timed pulses of light, some as short as 100 picoseconds. One way to create these pulses is with a Mach-Zehnder modulator. This device takes advantage of a particular wave property called interference. Imagine dropping pebbles into a pond. As the ripples spread and overlap, a pattern forms. In some places, wave peaks add up to become very large. In other places, they completely cancel out. The Mach Zehnder modulator does something similar. It splits waves of light along two parallel arms and eventually rejoins them. If the light is slowed down and delayed in one arm, the waves recombine out of sync and cancel, blocking the light. By toggling this delay in one arm, the modulator acts like an on-off switch, emitting pulses of light. A light pulse lasting 100 picoseconds leads to a depth resolution of a few centimeters, but tomorrow's cars will need to see better than that. By pairing the modulator with a super-sensitive, fast-acting light detector, the resolution can be refined to a millimeter.
It shows about the sensor technology development. They can detect more smaller or more precisely and small object, it says. Not only that, but based on the sensory technology, it can think, it can make their decisions. But to the decision, so therefore the next is a more important part. It is said the trolley problem is there. It is introduced in 1967 by this psychologist. One version is, but there are many versions. And one version is runaway trolley is heading down to the track towards the 5 workers who will all be killed if the trolley produces on its present course. Adam is standing next to the large switch that can divert the trolley onto the different track there. The only way to save the life of the 5 worker is to divert the trolley onto another truck, and only has 1 worker on it. If Adam diverts the trolley onto the other truck, the 1 worker will die, but the 5 worker will be saved. Which do you like better? Which will you do? It means it says なんだっけ、トロリープログラムっていうのはトロリーに5 people is being in this trolley, and it has a brake accident, so they will die here when some rock go to this rock. But some switches there to next truck, moving to the next truck. Some people is there. This is Adam is here. Adam can change its track. But some one worker, single worker is working here. So which is better? The 5 worker should be die, or 1 worker should be die. So therefore, that is the ethical problem. It is said. That is similar to the autonomous vehicles. The autonomous vehicle has to think which is better. Killing the many people, killing the single people, but to a single person. But the single person, when the single person is a baby, or the one person is the bike rider. He is a bike rider. The other one is a pedestrian. The male, female, the child, baby, adult, elderly people, which is better, it has to be synced by autonomous vehicles control system. So that is kind of the ethical dilemma will happen. ちょっとどれかありますかな。トロリープロこれ見てみるか。はい。
Imagine you're driving down a country road and a whole gang of people jump out in front of your car. There's an escaped convict, a toddler, a mother with a baby, a 95-year-old war veteran, and a small kitten called Pickle. You can't brake or swerve, you're going to kill one of them. Which do you pick?
The answer is, of course, you probably won't have time to make a considered judgment. You're just going to react on instinct. But what if you did have time? The technology of driverless cars or autonomous vehicles may give us time to make these difficult choices. Of course, there are no easy answers. The question is, what sort of ethical framework should we program into autonomous vehicles? To illustrate some of the dilemmas involved, we've recreated here a famous thought experiment called the trolley problem.
Down this stretch of track, a runaway train is about to career. In its path are 5 unsuspecting people who will all die if the train hits them. But there's a switch. It will divert the train onto another track, saving the 5, but condemning one unsuspecting person to certain death. In essence, you have to decide, do you kill one person who's not in peril to save 5 who are? So, will random passers-by flick the switch or not?
Okay, we're going to start it. I'm going to start the train. Okay, ready? Train's going. Oh, you moved it. You switched it. Yes, last minute intervention. He's going to die. You've intervened. You have to intervene.
Yeah.
Most researchers find, as we did, the majority of people will flick the switch.
What's interesting is when you change the specifics of the trolley problem just a little bit, you get very different outcomes. If you say, well, instead of throwing a switch, you have to push someone onto the track, and the train will kill that person, saving the 5. And people drastically change their opinions.
I mean, no, I wouldn't do that, but I can't tell you why.
You wouldn't? Would you do it?
No.
Does it feel like a different problem now?
Yes.
What makes this interesting with self-driving cars is you actually have to encode these kinds of decisions in software. We don't really understand why people are making these decisions, and we don't always know what kind of decision they'll make in a situation that we've never seen before. That's what makes this so complex.
This is not fully self-driving.
No, but almost. Car companies haven't really begun to answer these questions, but they're still pressing on developing driverless cars. In Gothenburg, Sweden, Volvo are building a production model available now that can keep lane and adjust its speed to keep up with the traffic, a major step towards a fully autonomous vehicle.
The state of the art is that cars can drive themselves, but they still require driver supervision. This car can accelerate, brake and steer itself, but I still have to be there. I'm paying attention to the road and have my hands on the steering wheel. When we talk about pure automatic vehicles where the driver doesn't supervise the driving anymore, these cars will drive really carefully. I mean, first of all, they will always follow the traffic rules. They will not speed, they will just follow the traffic rules as good as they can. And then they will drive really carefully. They will have a very good following distance. If they feel uncertain, they don't have enough sensor information, they will slow down. Everything in order to not cause any accidents.
Volvo believes that for the foreseeable future, any difficult moral choices will be in the hands of humans. But what do we do when the computers become all-knowing? It would be possible, for example, if a driverless car has to crash, for it to pick who to hurt depending on their net worth, whether they're obeying the rules of the road or their supposed value to society.
You could say, well, if I'm driving in a poor neighborhood, pedestrians are more likely to be poor, and I'm less likely to sue me, and they'll sue me for smaller amounts. Therefore, I can give them less of a buffer. I can drive a little bit more dangerously than I would in a wealthy neighborhood. And that optimizes your, that minimizes your exposure to liability. But most people would argue, and it's legal, most people would argue that's very wrong.
There's no doubt that, as the car company's videos suggest, autonomous vehicles will make our lives simpler, safer, and far less congested.
Please go ahead.
But they'll also force us to address some pretty fundamental ethical questions.
Thank you.
ということで、ファンダメンタルクエスチョンですね。で、だから、まあ、こういうふうに、フィッシュテイク、ね、 きも、これがメール、フィーメール、ディフェレンスとか、バイクライダーの場合は、in case of バイクライダー、one has a helmet, one has a bearing head とかね。or the crashing is the big truck か big truck か small wagon か which is better. Yeah, that is the kind of ethical problem. And also the vehicle must decide which is better, which is a better way to keep something, to maintain something. So that is very important. Of course, other problem is there in self-driving car. This is an ethical problem. But the technology, safety sensor is not always complete, not always completely. Stamped by the harsh weather, so therefore the heavy rain cannot work well. And communication, information sharing among vehicles is also important, but how to make the infrastructure problem is also there. And security and insurance and reliability, the law cannot be organized well, and the cost problem is also there. This kind of safety car is become more expensive. So therefore it is said, yes, autonomous car is yes good maybe. If all of the car on the road become autonomous, it's okay. All of the car is autonomous and it is communicate each other and make to avoid obstacle and avoid collision. But the transparent period, some of them is autonomous, but some of them is driver driving car. That kind of condition is not good, so that it makes the very confused conditions, maybe. So therefore, that becomes a problem for the autonomous car. But in China, the one city, smart driverless city is there, developed in near Beijing, it is said. The Baidu Apollo project, self-driving car tested on the public road. In this city, no driver car. って言われてるんですけど。ですね。if the new city and all of the infrastructure is organized at the beginning of its development, it's okay. So all of the car is autonomous car and all of the infrastructure is organized for the autonomous vehicles. That is good condition. New area.
一个车辆它要跑起来，它还是需要对周边环境有非常准确的一个感知。这个传感器相关的话，我们包括了我们上面这个转这个激光雷达，64线激光雷达，也包括我们这边相关的一些摄像头，包括我们汽车前后相关的一些雷达。
これラストイヤーですか。これがオートマスカーパート。オートマスカーパート。あと about 30 minutes remaining. Which part? Next. Which part we should talk? We should watch. なんかクエスチョンとかありますか？このセルフドライビングカーパートクエスチョンいいですか？ じゃあ move to the next part. 何がいいですか？ソーシャルサポート。ソーシャルサポート？ソーシャルサポートって何かどれかな？なんかアプリケーションオリエンテッドとか、なんだ、パーソナルモビリティパート。パーソナルモビリティパートですか？あるいはなんかガードロボットですか？とかクリーニングロボットとかさ、このなんかデリバリーロボットとかさ、Which how do you want to look? デリバリーロボットですか？デリバリーロボットですね。デリバリーロボットは、まあ、many delivery robot is developing now。例えばこれは、ドミノピザ。ドミノピザのデリバリーロボット。まあ、about 3 years ago, it is developed。これ、まあ、ドミノピザで、ここがなんか、ストックになってて、autonomous delivery vehicle and it's set to take the world of some。is four-wheel vehicle で compartment built to keep the customer's order pipe in hot and drinks トラビンなんたらかんたらでなんかショートカットとかこうまあちょっとイントロデュースタクションのところをちょっとビデオ見てみましょう。3分ビデオですね。これかもう何かこれ使うじゃん。
I'm Naomi Kyle here with IGN News. Domino's Pizza has unveiled what they're calling the world's first commercial autonomous delivery vehicle to deliver pizza in Australia. Domino's Robotic Unit, or DRU, was developed in collaboration with Robotics, known for making targets for live-fire army training. The DRU can reach speeds of roughly 12.5 miles an hour, overcoming obstacles in its path, and even navigate fences and driveways, although customers will have to collect their delivery from the curb for now. The DRU also makes conversation during deliveries and includes cameras to catch any potential pizza snatchers in the act. According to the CEO of Domino's, the DRU is completely safe. He said one of our inspirations for DRU is safety. It seems pretty crazy to us that we would use a 1.5-ton vehicle to deliver a few hundred grams of pizza. But Australian pizza will continue to be delivered by humans for the time being. The DRU isn't allowed on highways and can currently only deliver an average-sized pizza. For all of your pizza robot news, stay tuned to IGN.
まあこれはドミノピザの場合で、これは例えばスターティックテクノロジー、エストニアのスターティックテクノロジーのところで、まあこれ This is the used in EU countries and UE countries and and also the USA cities で、例えばなんだっけな、例えばちょっとこれ見てるんですか？これちょっとプロモーションすぎて面白くないか。例えばこれか、一番これでいいや。まあキャンパスデリバリーとかやってるって言われてるね。
Never seen a robot like this. It has to be the first time. What is this thing?
My first reaction when I saw the robot, I said, what? You're gonna do what? You're gonna do how? Okay.
Rather than spending time in line waiting for food or coffee, or having to stay nearby to the cafeteria, our technology allows employees more freedom to spend time how they want, where they want. Whether it's having a late lunch at your desk during a busy day, or going outside and enjoying a snack with colleagues, our robots can help.
So what we're doing is, we're using robots to autonomously deliver food, drinks, and snacks to customers.
We're enabling everyone to order food directly to their building or anywhere they want outside. Beyond the convenience of having food delivered, we aim to save people time. So how does it work?
A campus employee or visitor will go to starshipdeliveries.com,
download the app on your mobile device, and you're in there. That's it. Start ordering food today.
They open the app, and they're presented with many options that are available from the local cafeteria.
You can get a burger, you can get a Philly cheesesteak, you can get popcorn, you can get whatever you want.
They drop a pin on the map, and that pin represents where they're going to meet the robot. They finalize payment, and then they go to a screen that says how long it'll take till the robot arrives. Typically, it is 15 minutes or less. The kitchen receives a notification that a customer has just placed an order through the Starship app.
When we get an order, we stop what we're doing, we make that order first, get it out as quick as we can.
While the kitchen is preparing the meal, the robot starts to travel from either its most recent meeting point or from the staging area to the kitchen itself. The kitchen then places the meal in the robot and then dispatches it to the customer. The customer will receive a notification that says your robot's en route. The robot uses the most efficient and quickest method to drive autonomously to the customer. The customer will then receive another notification when the robot has arrived at the meeting point. The customer is then notified to come down and meet the robot. They'll be able to then unlock the robot and take their food.
So this small little cute robot delivered my lunch today.
まあそういうふうにスマートフォンアプリケーションでユーザーコンファメーションでオープンするっていうことですね。でだけど例えばここにあるのは We try to steal food from the delivery robot とかいうのをちょっと見てみるか。
If you request DoorDash to deliver something to you, this robot's going to show up at your house, and DoorDash will send you a text message. You'll click a link inside the text message, and the bot will unlock. You get your food. There are a bunch of cameras surrounding the robot. It's not complete 360 view, but it's close enough. And one of the craziest things it can do is climb curbs by lifting the wheels one by one until it finally hurls itself up onto the sidewalk. So you see this little bugger rolling around the street, 6 wheels, it's all smug, and the only thing that you want to do is first steal what's ever inside it, it's probably tasty, and second, just break it to pieces. So we were walking on the sidewalk with your robot and I stole it. What would happen in a real world scenario if that went down?
4 million people have met this robot. We haven't had any incident of theft or vandalism yet in over 20,000 miles of testing. In the future models, we'll have alarms when you pick it up, like a siren, so if you're running down the street with a robot, it's going to be causing a lot of attention. But most importantly, it's tracked to the nearest inch, so we know exactly where the robot is.
It was almost comical seeing how many people were following this robot around. There were plenty of people from Starship Technologies, which creates it. There were people from DoorDash, which is deploying it. And then there was our crew. It was very well protected in case anybody wanted to come and cause trouble. And then we did it. It took me 2 attempts to try to steal food from the robot before I was able to take it from its sealed compartment. The first attempt, the robot was completely locked solid. I tried from all angles. I had to pick the robot up, and I couldn't get it open. It's robot 1, human 0. Second attempt, I figured out a vulnerability in the robot's shields, and I was able to pry open the lid based off of an issue that clearly they hadn't taken care of and run away with a meal that would have been especially tasty. So we roll up to the restaurant, and actually really only the bot rolls and we're walking. And a human dasher walks by this bot and starts pointing at it and saying, "You, I hate you." And it was very clear that she viewed this bot as a threat to her job. Anybody who sees a robot start to automate even part of their job is going to be really upset. Jobs aren't something to joke around about. People depend on them for their livelihood, for what they use to feed their families. Is the plan to automate all DoorDash deliveries? Which type of deliveries do these things make the most sense for?
No, that's not the plan at all. We actually see robots as something that's very complementary to our human dashers, right? These robots are designed really well for the short distance, small orders that typically our human dashers don't want to take on.
Just like
まあいいや、ということで、you want to use this kind of robot? It's very convenient for you? あ、そうなんだ。まあいいや。はい。他にも the similar system is there. 他にこれとか、次のページは、next ページは、ZMP で in Japan でキャリローっていうやつがあって、これもデリバリーロボットですね。それからキャリローデリーとか言って、ZMP が this year it started some trial services about using the cloud computer and smartphone application, PC application and so on. So this delivery robot is developed. Also in the FedEx's robot and the German DHL's the delivery robot is also there. This kind of robot is まあなんかこうさっきの 6-wheel drive で to overcome the steps in the sidewalk and the usual road. But the 4-leg system and the plus something is there for the FedEx robot. And the in Germany robot, this is Deutsche Post company is developed this robot, a robot accompanying a mail delivery on their route and carries their回転です。っていうのがあって、これはデリバリーロボットで、インドアケースは、まあ、some delivery robot, Sharp Corporation is developed this. And also, これはサビオってカリフォルニアの、例えばこれホテル、in the hotel, some delivery, hospitality, high-rise to delivering and logistics. This kind of robot is commercially available now in many expensive hotels. あとはこれは PATH っていうのは Predicting Action of Human Bot とか言って、そういうモビリティロボットがありますよ。あ、まあいいや、これ本当のロボットか。はい。で、まあデリバリーロボットで、What kind of technology is necessary for delivery? What kind of technology is used in there?
Sensor.
あ、もちろんセンサーなんだけど、What kind of procedure is necessary? What kind of steps is necessary to realize this kind of delivery robot? まあデリバリーロボット。
Path planning.
え？
Path planning.
ああ、デリバリーロボットっていうのはマップが必要だよね、マップ。いや、マップ、シティマップとかマップが必要なんだけど、で、これがさ、だから、some decided area, small area is very acceptable to do because map is the preliminary prepared, and the delivery area is the preliminary decided. So therefore the pathway is the preliminary defined like this. So therefore, and also the human can check this area's condition. Where this kind of the sidewalk, the driver walks steps is there. Where is the zebra crossing? Where is the cross? Where should be crossed? Where should be walk? Which side should take? All of the information can be acquired preliminary. So therefore, the map after map path planning is necessary. Path planning. So the map preparation and the path planning is can be done in the offline preliminary pre-trip doing. But to the file delivery, file traveling. Of course, sensor technology is necessary. Sensor. The present dynamic condition should be acquired. So all the surrounding condition for this vehicle must be detected. So the pedestrian, the other people's walking condition, or the other vehicles condition, other pets condition, and the street's condition, and also on the sidewalk, some obstacle is there or not, it must be detected. And it changes its pathway, the planned path, but to the file delivering, it should avoid obstacle and tentatively change and go back to the planned path, for example, it must be. So the offline condition and file traveling, online control, both necessary. But one important point is the map information. So therefore, for the new condition, new situation is very, very difficult for this kind of robot. The map is this framework, one condition, and also the sensory, this kind of obstacle or the pedestrians is also the preliminary define some scenario, including some scenario, of course, because yes, the pedestrian can be predicted. Yes, pedestrian's condition can be predicted, and the vehicle's condition of the predicted, and the traffic signal's condition can be predicted. So all of the situation is already considered preliminary, and after that it can deal with. Completely new situation is very, very difficult. Completely new condition, new area is very, very difficult under the present technology. So that kind of offline information firstly, and online information file delivering is very important to realize this kind of robot. ということですね。これまあそうだからまあ何でもいいんだけど、クラウド使うのもいいんだけど、まあこれはアプリケーションだし、まあこれはinside of the building is very easier than of course the outdoors. これはなんかレストラン、フードレストランのフードデリバリーだし、これはワンホテルの yes, even in the another floor, but it's okay. Because it can communicate with the elevator system, for example, and the automatic door opening system, it's okay. So therefore it can, yes, it has, of course it has some map of the floors, and also the online detection about the obstacle is also must be walked by using sensors, mounted sensors, equipped sensors. この中見てみますか。
We named our relay robot after a lot of conversation and a lot of feedback from quite a few different people. But we landed on Wally because it was fun and it just stuck. When I first learned about relay, I had no idea what to think about this when I saw it in action. I thought this would be perfect for our hotel. When we first deployed the robot, it was pretty amazing, the whole network of sensors that have been built into this robot, because we were concerned that it was going to bump into things or run into people, but it's a very sophisticated piece of machinery, and it knows when people are walking by, or it knows if it's approaching a wall, and it navigates around that. So we were all quite impressed about that, and I still love watching it navigate through a crowd of people in the lobby. The learning curve for learning how to use the robot was very, very quick and very easy. The user interface is pretty foolproof, and within minutes of deploying the robot, our staff knew how to use it, and it was off and running. So before Wally, customers would have to go down themselves to Starbucks or come down to the front desk and buy something from the market. But now that we have Wally, people are calling down and asking for Wally to deliver Starbucks, which we're able to capture additional revenue from and charge a $2 delivery fee for. There's been a lot of conversation about how Relay Robot impacts RevPAR at the hotel. Looking at all of the data and the numbers, I'm confident that conservatively a 0.5% boost in our RevPAR index can be attributed to the Relay Robot. And this measurement is beyond numbers. It's based on smiles, and it's based on feedback, and it's based on people checking in at my hotel and saying, is this the hotel with Wally the Robot? Wally has been a PR magnet for this hotel, and really with very little effort. Because of his social media explosion, different media outlets have latched onto this and reached out to me for coverage. Oftentimes I'm asked, is Wally the Relay Robot going to replace people's jobs? And my response is absolutely not. What we've seen with Wally is higher guest satisfaction, very happy customers, which has resulted in repeat business and higher occupancy. Higher occupancy.
っていうんだけど、これいいですよね、ホテルの場合ね。それがまあちょっとレストランの場合、in this case of the restaurant, that is, sorry, that this video is in Japanese. But it's fine they using this robot because the labor shortage. Because main reason is because of the labor shortage. So if this robot works well, the human can only work for the food preparations, not for delivery. So therefore, this delivery can be done by robots, they think. It's one set to 250 million. The two is sets. So therefore, the one big issue is about this 250 million is appropriate for example, one person or one worker. How long it works, how long it takes. For example, 10 years, 20 years, 5 years, 20 years. It depends on this robot's reliability とか. But in many cases, maintenance cost is not so low. Then, for example, this robot is also has automatic battery, automatic electricity charge, energy charge is also there. But the battery should be replaced in some period, of course. And also the moving part, the wheels and gears and some other moving parts should be maintained and replaced in some period. So therefore the maintenance cost is not so low, I think. So therefore this company, this restaurant thinking, yes, it works 10 years, for example. So therefore the 25 million for each year is appropriate, they think. But the maintenance cost takes much more in some case. That is a very severe problem. So the maintenance cost reduction is very important for usage of this kind of robot. Not only once purchasing, but maintenance is also additional cost is there. We have to take care. というような話をしました。もう1分間だからいいですかね、大体ね。はい、this is the part of the delivery robot ね。あと何かな。朝こ これまあガードロボットとか、これもガードロボットとか、これはプリゾンガードロボットとか、コーリアンのプリゾンガードロボットとか、これはカリフォルニアのナイトスコープというガードロボットとか、これはナイトスコープのレイテストバージョンですね。とか、あとは例えばこのプラントサーベイランスロボットとかあります。ガードロボットとかね。これプラントサーベイランスロボットはモアなんかフィールドロボット。それからこれはホンダのなんかフィールドロボットがあります。そうですね。あとクリーニングロボットはまあこういうやっぱりホテルとかエアポートターミナルのクリーニングロボット、あるいはオフィスクリーニングロボット、まあ、最近あとは maybe you know the Roomba. Presently this terminal is gathering the garbage from this mobile robot, and then so therefore you don't have to take care about this robot for a month, for example. The battery charge plus the dust gathering is there. This kind of terminal is present. あとはなんかウェットもできるっていうアイロボットの、モッピング、ウェットモッピングができますよ。あとはダイソンもlatestly this new machine is delivered. ダイソンロボットとかですね。です。でした。